Chemotherapy remains the cornerstone of cancer treatment, but its limitations are clear: toxicity, resistance, and relapse, and thus the need for a novel anti-cancer agent that are potent, efficacious, and low toxicity is in dire need. Recently, there has been an increase in natural product research as an alternative anti-cancer drug due to their multi-targeting potential and chemosensitization as an anti-cancer agent. Our review, Unravelling Alpha-Mangostin as a promising anti-cancer agent, an overview of therapeutic effects, molecular mechanisms, and strategies to improve treatment outcomes, explore alpha-mangostin as a promising anti-cancer agent. Alpha-mangostin is a natural xanthone from mangostin, possessing various pharmacological properties. In our review, we compiled a comprehensive table using over 50 studies summarizing the anti-cancer activities and molecular mechanisms of alpha-mangostin, covering the experimental model, IC50 values, therapeutic effects, and key signaling pathways. In breast cancer, it doesn't just slow growth, but it actively drives cancer cells to die, halts their division, and blocks their ability to spread. In cervical cancer, it suppresses HPV oncogenes while also enhancing the chemotherapy's effectiveness. In ovarian cancer, it disrupts tumor growth and cuts off the cellular communication that contributes to the progression. In colorectal cancer, it attacks cancer stem cells and helps to overcome resistance to chemotherapy. In pancreatic cancer, it interferes with pathways that drive invasion and metastasis. In prostate cancer, it shuts down the androgen receptor signaling and triggers stress response that lead to cell death. In lung cancer, it increases oxidative stress, pushing cancer cells beyond survival. Beyond this, alpha-mangostin has shown activity in liver, gallbladder, oral, gastric, and even skin cancers, consistently driving cancer cells to die, limiting their spread, and enhancing the effectiveness compared to conventional therapies. And this is where it becomes especially compelling. While most drugs are designed to target a single pathway, alpha-mangostin works across multiple pathways at once. This multi-targeted approach is exactly what modern oncology needs to fight resistance and improve treatment outcomes. But despite its strong preclinical performance, there is a major challenge: the poor bioavailability. In animal studies, oral absorption is limited, plasma levels remain low, and the compound is rapidly cleared. So while the in vitro results are promising, translating them into effective therapy remains a significant hurdle. So what's the way forward? Nanoparticles and liposomal delivery systems to enhance absorption, chemical derivatives and prodrugs to improve solubility, combination strategies to exploit its chemosensitizing effects, and importantly, systematic ADME and toxicity studies to build a robust evidence base. But before any natural compound can be used as treatment, a question must be addressed. Is it safe? Because in oncology, efficacy alone is not enough. Safety is just as important. So what does the literature tell us about alpha-mangostin? Encouragingly, preclinical studies suggest that alpha-mangostin is generally well tolerated at tested doses. In animal models, vital organs such as liver, kidney, and heart remain largely unaffected. Hematological and biochemical parameters stay within normal ranges, indicating minimal systemic toxicity. Importantly, it does not induce the severe side effects commonly associated with chemotherapy, such as bone marrow suppression or gastrointestinal damage. This safety profile is further supported by zebrafish embryo studies, where even at higher concentrations, alpha-mangostin show minimal developmental toxicity, supporting its biocompatibility. However, important gaps remain. Long-term safety data are limited, and its toxicological profile has yet to be established. Taken together, our review consolidates evidence across multiple cancer types, providing a comprehensive overview of alpha-mangostin's preclinical potential as an anti-cancer agent against various cancer types. We hope this work not only supports future research, but also highlights the critical gaps that must be addressed before it can be translated into clinical practice. Thank you.